Hello, friends of chemistry. We're doing Module 13 practice problems. Number 1.
The chlorine smell of pool water is not in fact due to chlorine. When chlorine hits water, some of it reacts with the water in the following way. 2Cl2 plus 2H2O yields 4HCl plus O2.
Okay. Okay.
Oh yeah. The smell you get from a chlorinated pool is often the smell of the HCl produced in this reaction. What is the delta H of this reaction?
Okay. So, because we're not given any of the phase information, what do we have to, how do we have to get our information? How do we have to calculate this?
It's difficulty.
Yeah, the first thing we have to do is draw a Lewis structure. So we're going to look for the bond energy, right? So we're going to draw the structure and see the bonds and then calculate the bond energy, right?
Yeah.
So where is that explained to do? It's explained obviously at the beginning of the chapter because it's number 1. So that makes it pretty obvious. So it's going to be sorry. Explained on page 423, okay, and onward. So looking at bond energy. So to find the delta H, what does it say here on page 425, Martin, 13.6? What does it say? Delta H equals?
Delta H equals energy required to break bonds minus energy released when bonds form.
Where are bonds breaking? Are these bonds forming or breaking?
Breaking.
Breaking. And where are bonds forming?
On the
right over there. So the
products.
Okay, so this is the energy to break bonds, the energy in the products, right?
Yeah.
Minus the energy in the reactants.
Mm-hmm.
Okay. So what does Cl look like? Cl2. Chlorine, yeah. Where is chlorine in the periodic table?
Chlorine is 7A.
Okay, so it has 7.
Yep.
So obviously the bond is going to be here, right?
Yep.
So they each have 7, and there's a bond between them. And there's 2 of these. Right?
Yep.
How about the H2O? What does that look like?
The H2O. Okay, so H is in 1. O is in 6. H is, yeah.
Okay, and how about HCl? Oh, and there's 2 of these. Cl is 7.
Yep.
And there's 4 of these, right?
Mm-hmm.
You don't really have to draw 4 of these. I'm just saying that. And O2. What's the O?
It's well, it's a 6.
Right.
Sure. So it's a double bond.
So.
Okay, so HCl is 428.
Where's that? Here we go.
Kilojoules per mole.
Okay.
And oxygen, double bonded oxygen is 494. And HO is 459.
And how about the
Cl
CL?
is 240.
Okay. How many of these bonds do we end up having? So we have to all of these energies are going to have a coefficient depending on how many bonds there are of that and how many moles there are, right?
Yeah.
So of the chlorine bond, we have how many moles?
2.
2 moles, right? And so we've got 2 moles times 240 kilojoules per mole. Plus, how about the H2O? How many bonds do we have?
4.
Yeah, we actually have 4 of them. And what do we have to do?
Well, we gotta multiply.
Yeah, how many HO bonds do we have?
HO?
Yeah,
We
we
got
have 4 of
4.
them, right?
Yes.
Okay, and then what do we do?
We subtract 4
We're doing-
times 428 kilojoules. Then we subtract,
do we add that to it, right?
no,
Well, aren't we doing that?
well, we could if we wanted to make it more complicated, but since we don't, we'll just subtract.
Okay.
And then we subtract 1 times 494 kilojoules.
And these are all moles. So moles cancel. So we'll have
So
this is going to be 480 plus 1836. Right.
minus 1712.
And then minus 494.
494 equals 110 kilojoules.
So delta H.
Yeah, delta H is 110 kilojoules.
Okay. That is it for number 1.